Hi guys, this is Amrit. So today I am starting on with magnetic field due to current. This is the concept magnetic field due to current. So this is one wire. This one is one wire. This is not a straight wire. It's a tilted one. And in this wire current is I. And I am taking one small segment DL over here. One small segment of this wire, that is DL. So because of this DL segment, I need to find out magnetic field at point P. At point P, and distance from that wire to that point P, that distance is R. Now directly to find out this magnetic field, we have a Biot Savart formula. Of course we can derive this Biot Savart formula, but better just we write this Biot Savart formula. And this formula is like dV is equal to mu naught by 4 pi dl cross r divided by r cube. This formula itself called Biot Savart formula. So if you look at this formula, dl is current element. This dl is current element, a small segment of this current, and this r is position vector, and this r cube is magnitude of that position vector. Now this is formula for Biot Savart law. Now using this formula we can find out magnitude as well as direction of magnetic field. I will show you how. Let's say this one is one wire, one straight wire. If you see this one, this is one straight wire. If you hold this wire if you hold, and your thumb is in front of you, just like your thumb should be in direction of current and complete hand should be in front of you like this. So if complete hand is in front of you and thumb will be straight, indicating the current of the wire. So if you curl your finger, so finger direction will be direction of magnetic field. So if you see in this one, here this current will be, this magnetic field will be inside, and at this point it will be outside. For more specific, if you look at this wire, so if I hold this wire in, like if I hold this wire in hand, and thumb should indicate direction of this current, and your hand should be in front of yours, it means, and direction of thumb, direction of current only. So if you curl your finger, so here the finger will be into this plane and here finger will be outside of this plane. It means magnetic field at this point into this plane, and magnetic field at this point it will be outside of this plane. Now using this, I will find out magnetic field due to straight conductor. Magnetic field due to straight conductor. Now this one is one straight conductor, this thing, and at distance d I want to find out magnetic field at point P. First end of this conductor, this point making angle alpha at point P, and second end is making angle beta at point P, means this angle is alpha and this one is beta. Now I selected one small segment at distance x from here, and length of that segment I am taking dx. If you see that segment length, this segment length is dx, this length is dx, this length, and distance from this one is x. So if you look at this, I took one small segment dx, and this distance I am taking r, means this distance is r, this distance is x, and this one is d. What I have to find out? Because of this complete wire, I need to find out magnetic field at point P. This wire has a current I. At distance d from this wire, at point P, I need to find out magnitude as well as direction of magnetic field using Biot Savart law. Now if I make this separate diagram of this one to make it little more clear, if I make this diagram over here, see this angle I am taking theta, and that is small angle, due to that is small triangle, that will be d theta. This distance is d and this one is x. So if you see this angle is theta, it means this angle will be 90 plus theta, because this angle is theta, it means this angle will be 90 minus theta. So upper one will be 90 plus theta. If you see, this angle will be 90 plus theta, this one, and this angle is 90 minus theta. So if you look at this triangle, this one, or else you can look at this one, both are same thing. X divided by d is equal to tan theta, right? It means x is equal to d tan theta. It means if I differentiate this one with respect to d theta, so that will be dx is equal to d sec square theta, right? Now if I can use Pythagoras theorem over here, of course we can use, because this angle is 90 degree. It means x square plus d square is equal to r square. It means r square is equal to x square plus d square, and in place of this d square, in place of this one, this d square, I am writing d square tan theta, because see, in place of this x I can write d tan theta. So if I write d tan theta, so this is x square, so this becomes d square tan square theta to d square, means r square is equal to x square plus d square. In place of x square I am writing d square tan square theta. Now I can take d square common, and we know 1 plus tan square theta is equal to sec square theta. So what I got, r square is equal to this one, that will be equal to d square sec square theta. Now according to Biot Savart law, if I use Biot Savart law over here, according to Biot Savart law, this dB is equal to this formula already I explained. If you see this formula, so dB is equal to mu naught I mu naught I divided by 4 pi dl cross r divided by r cube. Now here dl is x. If you look at this, dl will be x. Here dl will be x. Now dl is not x, sorry, dl will be dx. So this dl will be dx, and r is r only. But if we see angle between these two, that angle is this one. Angle is 90 plus theta. So what I write, dl, in place of dl dx, in place of r only, but in place of theta there is a 90 plus theta. So I write sin 90 plus theta, and we know sin 90 plus theta very well, that will become cos theta. So this become cos theta, and 1 r of this one, 1 r of this one, and 1 r get cancelled. So I'll get this one. Basically this is r cube. This one is r cube. Now what I got, dB is equal to mu naught I dx cos theta divided by 4 pi r square. How I got? Because sin 90 plus theta, I am writing cos theta, and 1 r of the numerator getting cancelled with 1 r of a denominator, and this one in circle, whatever circle rotating, that is r cube. So now I'll get this. Now I'll get this thing. If I solve this one in place of dx, if you see that dx is equal to d sec square theta. See, dx is equal to d sec square theta. If you see this, dx is equal to d sec square theta. So in place of this dx, in this dx, I'll write dx is equal to d sec square theta and cos theta as it is. And in place of this r square, I'll write here d square sec square theta. If you see, this is d square sec square theta over here. Now, so after solving this thing, this complete thing, d square and 1d will get cancelled. If you see this one, d square and 1d will get cancelled from this, and here sec square theta and sec square theta will also get cancelled. So I'll get dB is equal to mu naught I divided by 4 pi. dB is equal to mu naught I divided by 4 pi cos theta d theta. Now if you see the limit of integration, guys, limit of integration is minus beta to plus alpha. If you see this one, this diagram, so limit of integration is minus beta to plus alpha. See this one, this angle is minus beta because it's below that line, below that d line, and this is above that d line. So it will be minus beta to alpha. So if I integrate this one from minus beta to alpha, we know integration of sin theta, where that will be, sorry, integration of cos theta, that will be sin theta. So from that sin theta we can put that value, and after putting that value I'll get this one. So final formula For magnetic field due to current carrying wire, if first end of the wire making angle alpha, a second end making angle beta, so that is given like this. This is the formula for this one. If first angle is alpha and second angle is beta, it means first end of the rod making angle alpha and second end making angle beta. So this is magnetic field formula, and using this we can find out direction as well. So if you see this wire current direction is up. So if you hold your thumb like this, one over here, so in that case here right side, here direction will be into this plane, here direction will be into this plane, and here it will be outside of this plane. Here it will be into this plane and here it will be outside of this plane.